All right, today we're going to be looking at different ways to measure solutions. There's lots of different techniques for concentration, and we've probably seen a few of them before. We remember molarity. We've seen this before. We're going to abbreviate that with a capital M, and let's remember that the formula for molarity is moles of solute per liter of solution. Let's take an example just so we're on the same page. And here's a typical example of a type of question you get asked. What's the molarity of 1 gram of ethanol, C2H5OH, and 101 milliliters? So the first thing we're going to want to do is find out how many moles of ethanol we have. If we know we have 1 gram, and the molar mass of ethanol is 46 grams. And so calculating the number of moles we're talking about, let's bust out our calculator. Let's make sure this is on first. We'll say 1 divided by 46, and this is how many moles we have. 0.0217. And now we want to find out if we have 0.0217 moles, what's our molarity? Molarity is equal to moles over volume in liters. We have 0.0217 moles of ethanol, C2H5OH, but we want to find what our concentration is, and if our volume is 101 milliliters, we're going to get that into liters by dividing by 1,000, right? There are 1,000 milliliters in a liter, and we get 0.215 molar. So we've seen that one before. That one's fairly straightforward, and we've also seen molality, which is a lowercase m, and this is moles of solute per kilogram of solvent. Let's get an example of this one. So here's a pretty good example. What is the molality of 38 grams of cellulose in 350 grams of water? So the first thing we need to know is how many moles of cellulose do we have if we have 38 grams. And if we know that the molar mass of cellulose is 180 grams. 180 grams, and so busting that out on the calculator is 0.21 moles. So what's our molality? Well, remember that molality is number of moles of solute per kilogram of solvent, and in this case our solvent is this 350 grams of water. So let's plug that right in. We know we have 0.21 moles of cellulose, C6H12O6, in our solvent, which is 350 grams. We want to get that into kilograms. So we're going to divide that by 1,000 because there are 1,000 grams in a kilogram, and we get a molality of 0.603 molal. Alright, so those are fairly straightforward, and we've seen those before. So here's a few that we might not have seen. Alright, this one's called mass percent, and it is something we've seen before. We did this in honors chemistry. We called it percent composition when we were doing it last time, and it's pretty straightforward when we're talking about a solution. It is simply the mass of solute divided by the mass of solution, and then we're going to divide that by 100 to get it into a percent. Let's get an example here. So we want to be careful because when they're talking about mass of solution, that's everything that goes into making a solution. It's the solute, which is in this case our sodium chloride, and our solvent, which is of course the water. So we're going to find out, and a lot of times we'll just abbreviate it, mass percent with just a percent sign. So what's the mass percent of this setup? We've got 15 grams of solute, that's NaCl. And the mass of solution is 15 grams of NaCl plus 250 grams of H2O, which is, of course, 265. So if I crank all this out, and we're also going to multiply this by 100, we should get that this particular solution by mass percent is 5.6%. NaCl by mass. That's a pretty easy one. All right, let's do this next one. This one's called mole fraction, and we're going to represent it with the Greek letter chi or chi, depending on how you pronounce it. And this one's pretty straightforward. It is moles of solute divided by total moles of solute plus total moles of solvent. And that's kind of clunky to write. So a lot of times we'll represent it, if we're looking for the mole fraction represented by the Greek letter chi, of A, it will be equal to the number of moles of A divided by the number of moles of A and the number of moles of B, where A is our solute and B is the solvent. So let's try an example of one that we would try that's set up like this. So here's one we could try. It says, what is the mole fraction of 1 gram of ethanol in 100 grams of water? So the first thing that we're going to want to do is find out how many moles of each of these we have, and we used ethanol before. So how many moles of ethanol if we have 1 gram, and the molar mass is 46 grams in 1 mole. And that's fairly straightforward, which is 0.0217 moles of ethanol, C2H5OH. We want to add this to how many moles of our solute, which is H2O, and that's fairly easy. We have 100 grams of H2O. And the molar mass, I'm sure you all remember, is 18 grams. That's 5.56 moles of H2O. So what we're looking for is the mole fraction of C2H5OH. And of course, we know we have 0.0217 moles of C2H5OH. And the total moles of both solute and solvent will be, of course, 0.0217 moles of the ethanol, C2H5OH, plus the 5.56 moles of H2O. And when we bust these out on the calculator, we get a mole fraction of 0.00389. And there's no units for mole fraction. All right, let's try one more. And this one is fairly straightforward and a bit simpler. All right, this last one is pretty straightforward. It's called normality, and it's got an interesting definition. It is the number of equivalents of solute per liter of solution. And this usually applies to acids and bases. And what we mean is the one equivalent, or one normal, equals 1 mole of H plus if we're talking about an acid, or if we're talking about a base, 1 equivalent. 1 normal is 1 mole of OH minus. So if we had a solution, what is the normality, we would say? What is the normality of 3.75 molar H2SO4? Well, let's remember that H2SO4 dissociates into 2H+. And so, anytime we had 3.7 molar H2SO4, it would give us 7.5 molar H+. So, even though H2SO4 is 3.75 molar, it is 7.5 normal. All right, take that for a spin.